Hey everybody, and welcome back to another lecture with Coding with Roby. And in this video of the Python Bootcamp, we are going to learn about inheritance. Inheritance allows you to inherit methods and attributes from the parent class. This allows us to create subclasses, but still get all the functionality of the parent class. And we can add new functionality without changing the parent. If you've been following along in these series, you'll see that I made some changes to the student class. The student class currently has the init method, which initializes a new student with the first name and last name. And it has a function called greetings, which returns, hello, I am self.firstname, self.lastname. I now have two students, Eric Roby and John Miller, and both students can print the greetings message. Now let's create a subclass. We can create this by doing class college student. Let's add parentheses, and within the parentheses, let's type in student. What this means is student is the parent class of college student. Therefore, college student will inherit all methods and attributes that student has. And I'll type in pass right now so no errors are thrown. Let's now change student 1, which is Eric Roby, from student to college student. If we rerun the application, we'll still get hello, I am Eric Roby and hello, I am John Miller. Even though student 1 is now a college student instead of a student, it still inherits the greetings and the initialization of regular student. Let's add a new initialization field for college student. We can do this by saying def init and then passing in self, first name, last name, and major. Your first thought may be to grab self.firstname equals first name and self.lastname equals last name from the parent, which is student. However, we want to keep things dry and simple. So to call the parent functionality, we can use something called super. So we can type in super parentheses. So now we're going up to the parent level, which is student. And now we can say dot init, the first name and last name. So what this means is when a college student is created, we'll call the student initialization to pass in the first name and last name. And now we can just say self.major equals major. Now college student needs one extra field, which is major. If we rerun the application right now, we'll see that college student breaks because it's missing a required field, which is major. So let's type in computer science. If we rerun the application now, we'll see that it prints, hello, I'm Eric Roby, and hello, I am John Miller, because it's passing in the greetings method from student to college student. However, student 1 has one additional field, so we can print student1.major and return to the terminal computer science. If we change student 1 to student 2, the application will break and we'll get an error because no attribute exists called major. If we add math to the end of student of John Miller, the application breaks because John Miller is referring to the student parent, not the college student, which holds the major instance variable. Let's start by creating a new class called non-college student. And again, we'll inherit from student. We will use the special initialization function, which passes in self, first name, last name, and for the last variable here, let's create a variable called future adult job. Let's call the parent functionality, so we'll type in super.init, and we'll pass in first name and last name. We will then say self.futureAdultJob equals futureAdultJob. Let's now change John Miller to a non-college student. Because student 2 is now a non-college student, we'll have to add the additional field of a future adult job. I'll pass in doctor as future adult job. I'm going to add a new print function of student1.major. If we rerun the application now, we'll see that we get computer science, hello, I am Eric Roby, computer science, hello, I am John Miller. Let's now create another print function and pass in student2.futureAdultJob. In the final response, we'll get doctor. Now, we can override methods from a subclass to a parent class. If you override a method and do not use super, it'll call the current class method, not the parent class. So within college student, let's create a new function called greetings, the same name as the parent student. Here we'll return self.firstname is a college student. If we rerun the application now, we'll see that Eric is a college student is printed to the terminal for greetings for college student. And for John Miller, who is a non-college student, greetings prints, hello, I am John Miller, because non-college student doesn't have a greetings method, so it calls the parent automatically. Let's create a new method for non-college student called grow up, so def grow up self. And within the grow up method, we'll pass in return f. When I grow up, I want to be a self.futureAdultJob. We can change student.2.futureAdultJob to grow up, and we'll print, when I grow up, I want to be a doctor. Alright, and this concludes inheritance in Python, and I will see you in the next video.